Welcome to Two Projects. In this video, we are going to explain the project Farm Supply Food Supply Chain Management using Blockchain Technology. Introduction. This project seeks to modernize the food supply chain, that is FSC, using Ethereum blockchain with a primary focus on enhancing efficiency, transparency, and security. By leveraging Ethereum's capabilities, we aim to streamline FSC operations, provide stakeholders with clear insights, and fortify transactional security for a more reliable supply chain. Traditional FSC methods face challenges, including inefficiencies, a lack of transparency, and susceptibility to fraud. Manual processes hinder traceability and compliance verification. So, this project addresses these issues, recognizing the need for a more effective and secure approach. So, to tackle the identified challenges, we integrate Ethereum blockchain and smart contracts. Blockchain is like a digital ledger that records transactions securely and transparently. In our case, it is used to store information regarding product origins, verification processes, and authenticity checks. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. So, this initiative capitalizes on Ethereum's blockchain, renowned for its smart contract capabilities. These contracts on the Ethereum network not only secure but also meticulously track critical product details, further elevating transparency and reliability in the supply chain. Objective of the project. So, as I mentioned earlier, the primary objective is to develop an efficient and transparent food supply chain management system. The main aim is to enhance the traceability and authenticity of food products, ensuring a reliable and secure supply chain from production to consumption. The aim is to utilize blockchain technology to establish a distributed and tamper resistant ledger for real time tracking of food products. This objective enhances transparency, reduces fraud risks, and ensures the integrity of data within the food supply chain. And we aim to implement smart contracts using Solidity on the Ethereum blockchain. These contracts improve the efficiency of recording and validating critical information. Integrating Ethereum enhances the overall security and reliability of the food supply chain management system. Requirements needed to execute this project are software requirements, Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, Solidity. Framework used is Flask. Frontend languages used are HTML, CSS, JS, and Bootstrap 4. Hardware requirements needed are processor of i5 and above, RAM of 8 GB and above, ROM of 20 GB and above. To execute this project, we have designed few modules. So we have created 5 different users, namely farmer, manufacturer, distributor, retailer, and customer. So users across all modules undergo a streamlined registration, providing essential details such as personal information and a unique username. A secure password is established during registration. Subsequently, the login process involves entering the respective username and password for secure access. Now we'll see the farmer modules. So these are the farmer modules. So, farmers play a crucial role in the supply chain by cultivating and producing agricultural goods. In the system, they register, log in, and contribute to the supply chain by adding details about their agricultural products. This initial step ensures the entry of raw materials into the supply chain. So these are the manufacturer modules. So manufacturers undergo registration and login processes. Their primary role involves checking available products and making purchases. This module reflects scenarios where manufacturers may purchase raw materials or intermediate goods from farmers or distributors to further their production processes. And these are the distributor modules. So, distributors serve as intermediaries managing logistics and transportation of products from producers to retailers. They register, log in, and contribute to the supply chain by adding products to their inventory. This step ensures efficient flow of goods and facilitates their distribution to various retail points. These are the retailer modules. So, retailers, after registration and login, gain access to functionalities like selling products and generating QR codes. This empowers retailers to manage inventory efficiently, enhance product visibility, and facilitate seamless transactions with customers. And these are the customer modules. So, customers register and log in to authenticate scans and purchase vegetables. So the authenticate scan feature ensures product legitimacy, building trust in the supply chain. And the buying process is user friendly, offering a secure and transparent shopping experience. Blockchain integration. So, blockchain's distributed software design is leveraged to transform how information is exchanged among various entities in the supply chain. Instead of relying on a centralized authority or database, the information is stored across a network of nodes, ensuring decentralization and increased security. This reduces the risk of a single point of failure and enhances the resilience of the information exchange process. And Ethereum smart contracts are employed to ensure secure crop tracing and facilitate transparent and traceable communications. Smart contracts enforce the rules governing crop tracing, ensuring that the process is secure, transparent, and tamper resistant. This enhances trust among participants in the food supply chain. Blockchain is utilized to maintain an immutable ledger, meaning that once information is recorded, it cannot be altered. The use of the interplanetary file system, that is IPFS, for linking adds an extra layer of security and decentralization. IPFS allows for the storage and retrieval of content using a content address system. This content is stored in the form of blocks. Each block in a blockchain is linked with a unique hash code. These blocks are maintained across multiple nodes or servers. Before storing new records, blockchain verifies the hash code of each block. If any block data is modified, it results in a different hash code, triggering security alarms and ensuring the integrity and immutability of the data. Therefore, the combination of blockchain and IPFS creates a tamper resistant record of communications where the immutability of blockchain meets the distributed and content addressed features of IPFS. And blockchain technology is applied to eliminate the need for intermediaries, transaction records, and centralized authorities in the food supply chain. Through the decentralized nature of blockchain, transactions and information exchange can occur directly between relevant parties without the need for a trusted intermediary. This reduces costs, minimizes the risk of fraud, and enhances efficiency in the supply chain. And we have used Ganache in this project. So, Ganache is a user friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in depth blockchain expertise. Ganache offers detailed transaction information, including sender, receiver amounts, gas usage, and success status, aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. This transparency simplifies monitoring and verification processes. And Ganesh lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is gas, was used. Ganesh also enables data retrieval from stored blocks, allowing developers to access and analyze specific block information. And we have also used MetaMask in this project. So, MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to dApps, making interactions with blockchain applications easier. So, in this project, MetaMask ensures secure Ethereum transactions, promoting transparency by showing the deduction of ETH as fees. This transparency maintains accuracy and ensures confident, reliable financial interactions within the system. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is contracts folder in which I have Solidity files. They handle data structures, functions, and events with modifiers for validation. This is sample folder in which I have these images which will be loaded into the application later. This is static folder. It consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is run.bat file to start the supply chain management system, and this is the run.bat file to start the IPFS server. So IPFS is a decentralized file storage system for secure and distributed data sharing. So blockchain is effective for recording transactional data, but for large file storage, it integrates with IPFS. Now double click on it. So we can see the IPFS server has been started. Minimize this. So before running the run.bat file, first we need to host the server. For that, open the Ganache. So we can see the server has been hosted. Now minimize this. Now double click on run.bat file. Instead of executing the project through command line interface, we have created these run.bat files to execute the project. So the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So first we'll do all the registrations. First we'll register as farmer. Click on farmer register link. So here we have to fill in all these details and click on add farmer button to register. So username would be farmer. Give the password. Give the contact number. Give the email ID and the address. Now click on add farmer button. So here we can see farmer sign up task completed. So all these farmer details will be stored in blockchain in a form of block. So we can see that in Ganache. So we can see a block has been created in which all these farmer details will be stored. So we can retrieve the data from here. Now minimize this. Now we'll register as manufacturer. Click on manufacturer register link. Fill in all these details. Username would be manufacturer. Give the password. Give the contact number. Give the email ID and the address. Click on add manufacturer button. So we can see manufacturer sign up task completed. So again, all these details will be stored in blockchain in a form of block. We can see that in Ganesh. We can see a block has been created in which all these manufacturer details will be stored. Minimize this, and if we see in MetaMask, click on the Chrome extension. We have to enter the password here. So we can see I have a balance of 99.9829 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. So, in the context of a blockchain, transactions refer to the actions or operations that are recorded on the blockchain ledger. Now we'll register as distributor. Click on distributor register link, fill in the details. Username would be distributor, give the password, give the contact number, give the email ID and the address. Click on add distributor button. So distributor sign-up task completed and the details will be stored in blockchain. Now we'll register as retailer. Click on retailer register link. Username would be retailer. Give the password. Give the contact number. Give the email ID and the address. Click on add retailer button. The retailer sign up task is completed. So we can see in Ganache, blocks are being created in which all these details will be stored. Minimize this, and now we'll register as customer. Click on customer register link. Fill in the details. Username would be customer. Give the password. Give the contact number, email ID and the address. Now click on add customer button. So the customer sign up task is completed. Now we log in as farmer. Click on farmer login link. So here we have to give the credentials of the farmer, username and password, and click on submit button. So we have logged in as farmer, and here we can see add product and logout links. Click on add product link. Here farmer can add new product details to the system. Fill in all these details. Product ID would be 1. Product name is tomato. Product quantity in kgs would be, I'm giving it as 100. Price per kg would be 30. We have to upload the product image here. Click on choose file button. So from samples folder, I'm selecting this image and click on open. The image is loaded. Now click on submit button. So we can see the product details added successfully. So all these product details will be stored in blockchain in a form of block. We can see that in Ganache. So we can see a block has been created in which all these product details will be stored. Minimize this. Now click on logout link. Now we log in as manufacturer. Click on manufacturer login link. Give the credentials, username and password of manufacturer and click on submit button. So we have logged in as manufacturer, and here we can see check product and purchase link and logout links. Click on check product and purchase link. So here manufacturer can view list of products details added by the farmer. So we can see product number, product name, quantity in kgs, product price per kg and the image of the product. And here we can see a click here to purchase link. So by clicking on it, we can make the purchase. Click on it. So here we have to enter the quantity we want to purchase. I'm giving it as 40 kgs. Now click on submit button. So we can see details are saved to blockchain. So all these details will be stored in blockchain in a form of block. Now click on manufacturer screen link. Click on check product and purchase link. So here we can see the action column has been updated, that is already purchased. Now click on logout. Now we log in as distributor. Click on distributor login link. So give the credentials, username and password of distributor and click on submit button. So we have logged in as distributor and here we can see add product and logout links. Click on add product link. So here we can see all the details: product number, product name, quantity in kgs, product price per kg, manufacturer purchased quantity and the image of the product. And we can also see a click here to submit purchase link. So by clicking on it, distributor can confirm the purchase of 40 kgs from the manufacturer. I'm clicking on it. So here we have to enter the quantity we want to purchase. So I'm giving it as 30. Now click on submit button. So we can see details are saved to blockchain. So in Ganesh, we can see the blocks are being created. Minimize this. Click on distributor screen link. Click on add product link. So here we can see the action column has been updated, that is already submitted. Now click on logout. Now we log in as retailer. Click on retailer login link. Give the credentials, username and password of retailer. Username is retailer. Give the correct password and click on submit button. So we have logged in as retailer and here we can see sell products and generate QR code link and logout link. Click on sell products and generate QR code link. So here retailer can view all the details about pharma added products and purchase made by the distributor. And we can also see a click here to sell link. So by clicking on it, retailer can initiate the selling process. So I'm clicking on it. So here we can see a QR code is generated. So by clicking on this link, we can download it. So it contains product details for customer visibility and verification. I'm clicking on it. So we can see the QR code image has been downloaded. Now click on retailer screen link. Click on sell products and generate QR code link. So here we can see the action column has been updated, that is already sold. Now click on logout. Now we log in as customer. Click on customer login link. Give the credentials, username and password of customer and click on submit button. So we have logged in as customer. So here we can see authenticate scan, buy vegetables and logout links. Click on authenticate scan link. So here we have to upload the downloaded QR code image for product verification and visibility. Click on choose file button. Upload the downloaded image and click on open. The image is loaded. Now click on submit button. So we can see the QR code verification is successful and we can see the product details. So here we can see list of products added by farmers and we can also see quantity purchased by distributor. Now click on customer screen link. Click on buy vegetables link. So here we can see all the details and we can also see a click here to buy link. By clicking on it, we can make the purchase. Click on click here to buy link. We have to enter the quantity we want to purchase. I'm giving it as 10 kgs. Now click on submit button. So we can see purchase completed successfully. So all these purchase details will be stored in blockchain in a form of block. We can see that in Ganache. So we can see the blocks are being created. Now click on any block. So here we can see block hash and transaction hash. Click on transaction hash. So here we can see sender address, to contract address, gas used, gas price, gas limit, and the transaction data. Now minimize this, and in the MetaMask, click on the Chrome extension. We have to enter the password here. So we can see the ETH balance remains unchanged after each block creation because the project's actions don't involve significant ETH transfers. So this is normal as not all operations lead to substantial balance changes. Now click on customer screen link. Click on buy vegetables link. So here we can see the action column has been updated, that is already sold. Now click on logout. So the conclusion here is the integration of blockchain technology marks a transformative step in the food supply chain, redefining how information is exchanged and transactions are conducted among diverse stakeholders. Through the use of Ethereum smart contracts and a tamper resistant blockchain, the project ensures secure crop tracing and transparent communications, bolstering the overall security and reliability of the supply chain. The project successfully eliminates the need for intermediaries, transaction records, and centralized authorities, embracing the decentralized nature of blockchain. This reduces dependency, lowers costs, and streamlines processes within the food supply chain. And the combination of an immutable ledger and the integration with the interplanetary file system, that is IPFS, creates a robust record keeping system. Each piece of information is uniquely identified and linked, providing a tamper resistant and permanent record of communications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.